So, who had a question about the quiz I just returned?
Can we just do number 2?
Which one?
Number 2.
Number 2. We want to write, thank you, Jared. We want to write the equation of the exponential. So the equation that we are shooting for is y equals a times b to the x. That's what an exponential looks like. So I've given you 2 points. What are you going to do with these 2 points? Whoa, we got to remember this. What do we do with those 2 points? Which one do we plug in first? The one with the 0. So negative 3 equals a times b to the 0. Now, what is b to the 0? 1. So, hello, good to see you. Oh, Precal stops for no one, Angel. So negative 3 equals a times b to the 0, but since b to the 0 is 1, like you said, a is negative 3. So now we have y equals negative 3 b to the x. Abby, I'm doing this for you. You need to be paying attention to me.
No, I am.
Now, the other point we're going to plug in now, negative 48 and 2. Now, to solve this, this is going to be kind of a common theme as we work through lots of different problems that come out like this. We must divide first. We have to divide first. So negative 48 divided by negative 3 is 16. So b squared equals 16, which means b equals 4. So now I have my a and my b. I can write my equation y equals negative 3 times 4 to the x. And we do not combine the negative 3 and the 4. We leave them as 2 separate numbers. They are 2 separate numbers. Anybody else have a question about the quiz? Something on the quiz that you weren't sure about?
Just to find the percentage of k, we minus that total from 1.
It's how much different from 1 it is.
Okay.
So listen, your percentage growth or decay is how much different from 1 you are. So if your number is 0.98, how much different from 1 is that? 0.02? So that's a 2% decay. Remember, the difference from 1 is how much you're growing or shrinking. Anything else? From the quiz. All right, let's look at our homework. Let's see, 1 to 24. Here, Jack, you do it?
Yeah, Bryce is trying to find it.
Why are all these I didn't know you guys. Why is it
He actually did it without her. But I helped him.
I helped him.
What was homework? What was it? Oh, no homework. No one here saying it was homework. Guys, nobody that I have. Okay. I don't even have. I just said that the homework was due after.
Oh.
What do we have here? Yeah, no homework at this entire table. So Baumgartner, Brady, Schuldemeyer. Okay, how about this table? Anybody here do homework? Any homework at this table? Okay, so even your excuse that you were gone, you have to do it, you gotta turn it. Okay, Thomas is Rock is Okay. Well, the four of you that did your homework, do you have any questions? Any questions at all? Bryce, put your hand up. All right, let's take a look at number 21. For those of you that are interested, we are on page 308. And we're looking at problem number 21. This is one of our properties. Do not be frightened of it. Oh wait, this is number 21. Do not be frightened of it. It is one of our properties. 10 to the log base, well 10 to the log 0.5 power. Now, when we see just log, there's an understood base right here. What is that base? 10. When these two numbers match, the answer is the other one. So that's just 0.5. You don't even have to show any work. That's just a bing, bing, bing if you know your properties. Okay? That property says 10 to the log base 10.5 is 0.5. Anybody else who did the homework? Bryce?
17.
17, ln 4 through E. Okay, the first thing I want to mention is, and I don't know how much I emphasized this the other day, but when we are in logarithm land, we do not like radicals. We want to get rid of that radical. Okay? How can you write the 4th root as an exponent? To the 1/4. So this would be ln e to the 1/4. Remember, the 4th root is a 1/4 exponent. Now, what does this mean, ln? It's natural log, but what does it actually mean? Log base e. So this is the log base e of e to the 1/4. Now that's a property too. When these two numbers match, the answer is the thing that's a little frustrating for me is on that homework literally would have taken you 5 minutes to do if you knew the properties. That was not a long assignment because none of the problems required you to do any work. They all came out like this. But we'll do better tonight, I'm confident. So let's get our calculators out. We're going to press a few buttons here today. All right. Do we all have out our handy-dandy calculators so that we can press some buttons? You will see your log and ln buttons are right down here. Right?
Yeah.
Mrs. Ford, my mom dropped off my folder. Can I go get it?
Yes. And you know that because you checked your phone when you weren't supposed to be checking your phone.
Yes. Sorry. It was important.
Okay, I'm not going to let you people ruin my day. I'm going to press my buttons on my calculator now. Okay, here's how this works. We want the log of 8.61, so we do exactly what you would think we do. We press log, and as soon as you do that, did it throw up some parentheses for you?
Just one.
So you just put in 8.61, close those parentheses and press enter. Now, let's pay attention to the directions. Do we have our note sheets out? We're doing the problems in the note sheets now. We are on the back side of page 26. Now, the directions say, round to the nearest 10,000. You got a whole bunch of decimal places on here. What do we mean by 10,000? How many is that? 4. So we're going to round this off to 4 decimal places. So 0.9350 will be our answer. Unless you have your logarithmic tables memorized, you are dead meat if you don't have a calculator. So you need to make sure you have a calculator with you every day. Okay, let's try the next one. Okay, now look. The next one says ln 12. Well, we're going to do the same thing, only we're going to use our ln button this time, right? So we're going to press ln 12. Now we're rounding off to 4 decimal places. So 2.4849, is everybody okay with that? Now, Katie Bumgardner is working ahead. She said the next one doesn't work. And she's right. When you type that in, you get no answer. Now, it's depending on the calculator you have, it's going to give you a different message. It might say error domain. It might say unreal, something. The fact is, kids, listen. You cannot take the logarithm of a negative number. It will never work. And that's because, if you think back to your BFFs, this was the logarithmic curve. This was the picture, your BFF, for logarithm. What x's have we plotted? This is y equals ln x. This is the picture of it. What x's are plotted? Just positive. There's no x's over here, are there? You can't put a negative number in that spot. So, looking down my list, this one is not going to work, and this one is not. Oh, this one's not going to work. You will never, ever, ever be able to take the logarithm of a negative number. It is not going to work. Now, can I take the logarithm of fractions? Absolutely. Decimals? Absolutely. But not negatives. Suzanne, you paying attention?
Yeah.
Tyler?
Do you have any extra note sheets?
You got these a long time ago, honey.
I just looked through literally everything I have.
I'm sorry. They weren't handed out when you were absent.
I'm not saying.
I know. I don't have any more. Take a picture of somebody's. We're on the back side of page 26. Okay, log 15.47. Here we go. Log 15.47. Now, you're going to have to round this one. 1.18. What do you think? I'm doing log 15.47. Kieran, are you typing this in?
Tyler's taking a picture of my thing.
Okay. Okay, you need a calculator out. Okay, now you need to type it in. Right here, it's written on the board.
I've got it done.
Okay, what did you get?
1.1895.
9.5, that's what I was waiting on, 9.5. That's how that one's gonna get rounded off. All right, how about this one? Now don't panic. As soon as you hit ln, it throws in those parentheses. Just do 1 divided by 23. That's what this is, 1 divided by 23. Ooh, I got a negative number, that's okay. Negative 3.1355. The answer can be negative. It's this guy that can't be negative. So there's only one left. My favorite number, the log of 1977. What did we come up with? 3.2960?
Oh, we gave it to me.
How are we? We okay with that? All right. Then now we're going to talk about the most important thing that we have talked about in a very long time. This is huge. We are going to solve some logarithmic equations. These are all logarithmic equations. And it's very easy to do, but you've got to remember this. First of all, what's the base on this logarithm? 10. So I'm going to go ahead and put a 10 there. When you have an equation of a logarithm, and you only have one logarithm. Now later we're going to have more than one logarithm in the problem, but for now we have one logarithm. You must translate the equation into an exponential equation, and that's really easy to do. You do it the same way every time. You take 10 to the third power, and that will equal x. So watch how my hand flowed making that equation. It's 10 to the third is x. 10 to the third is x. That's the way we translate an exponential, or excuse me, a logarithmic equation into its exponent form. 10 to the third equals x. Well, shoot, that's easy. What's the answer then? 1,000. So the answer to the problem is just 1,000. Now look at B. Now this is all we have to do the rest of the period, so we're going to take our time. This is the second question. You're going to solve this. You're going to tell me what x equals.
10 to the negative 1.
So first you're going to put your 10 in there because that's the base, and then you're going to translate it. Thomas, look up here. We translate it by saying 10 to the negative first equals x. So 10 to the negative first equals x. Now, stop. What does 10 to the negative first mean? You flip it because the exponent's negative, so it becomes 1/10. Remember, negative exponents mean 1 over. You flip them. All right, let's take a look at the next one. Once again, I'm missing a base, right? So I'm going to go ahead and put a base in there. I'm going to put in a base of 10. Now I'm going to translate this. How will this translate? Patrick, Troy, why are you talking? Talking about logarithms? 10 to the negative 2 equals x. 10 to the negative 2 equals x. Watch how I write it down, the order I write it down. 10 to the negative 2 equals x. Now what does 10 to the negative 2 mean? 1 over 10 squared. And 1 over 10 squared is 1 over 100. Perfect. Ethan? No. That would be fine. Now, what about this? What does this mean? Don't put a 10 in this problem. This means the log base e. This means the log base e. So how is this one going to translate? E to the 4th equals x. E to the 4th equals x. And the answer is just e to the 4th. Now, we could get a decimal, we could get a decimal for that on our calculator, but we're not going to. We're just going to leave it e to the 4th. How about this one? This is log base e, so e to the 6th equals x, and that's your answer. It is that easy. And then I got wild and wacky and threw this extra number in here. Any ideas about what we might do with this? Divide both sides by 3. This is just an equation. You are allowed to do all the things you do to equations. Divide by 3. Then what does it say? Log x equals 1, and we know the base on this is 10, so we can translate it into
Log 10.
no log.
10 to the 1st.
10 to the 1st equals x. And what's 10 to the 1st? 10. Okay, here are the next two. This guy. Divided by negative 2. So ln x will actually equal negative 2. Now what does ln stand for? Log base e. ln is the same as log base e. Now translate that. E to the negative 2nd equals x. E to the negative 2nd equals x. What does e to the negative 2nd mean? 1 over e squared. So the answer to the problem is 1 over e squared. Step 1, divide by negative 2. Step 2, rewrite ln as log base e, and then translate it. E to the negative 2nd equals x. base here? 10, so let's go ahead and stick that 10 in. Now we're going to translate this. What would it be when we translated it?
10 to the 1/2.
10 to the 1/2 equals x. Is everybody okay with that? Now what in the world does 10 to the 1/2 mean?
Square root.
Yes, the square root of 10. Very, very good. Remember, radicals are fractional exponents. When you have a fractional exponent, the denominator tells you which root you're taking. So this is a square root problem. The square root of 10. Good job. All right, how about this one? Well, we're going to put a 10 in there, right? Because LOG means base 10. So we'll say 10 to the 1/3 equals x. And then we'll say, wait a minute, 10 to the 1/3, that means cube root. So x is the cube root of 10. Last one. We're going to rewrite it as log base c of x equals 1/4. Now, I always do this. You don't have to rewrite it. If you are getting comfortable knowing ln is base c, you can skip this step. I'm going to write it down. Then I'll translate it. E to the 1/4 equals x. And what does e to the 1/4 mean? The 4th root of e. Perfect. All right, we're going to practice a little bit now. That's all we're going to learn today. This is huge. This notion of how you translate, that is absolutely huge. So that's the whole idea for today. We're going to spend the rest of the period doing some review work. All right, so if you get out a piece of paper, I'm going to put some problems up here. You're going to work on them, and then we're going to put them on the board, all right? We're going to recap everything we've learned so far in this little unit.
I want your hair. My hair? No. Yes, and your hair. I just want long. Mine doesn't grow. My hair grows slowly. My hair takes like. I don't think it has. It has grown a little bit though. It has. Yeah. It's grown a little bit. I just want it to be like here. It looks long. I like it. That's what I always say. Like if you grow it out of something weird. Yeah, I feel like yeah. I don't want to go like super long. I just want to I want to cut. Ella Hicks is gonna cut her hair after before college. She looks so pretty and older. Why is she not cut it? Here's really. She's always wanted to get like a. Like what's her name? Yeah, what's her name? Really pretty Maya? No. Julianne Huff. No, not Julianne Huff. She's tan. Pretty. Maya. It's the most generic description. Brown hair. No, I don't know. She said it was Zendaya. I don't know. Mia? Well, of course we know her. You'd be like, oh. I'm not having that one. She's beautiful. Like, she's the one people talk
Yep, it is.
Oh, so it's me. Mila? Short hair. I have Mila. Lauren Carr. She's not a short hair. Mia? What'd you say?
There's no way it's less than.
I don't know. She's this is gonna bother me. What's in a music that you had to take Stella? Like, and she had to go to the dance for like kids and then make a dance clothes for her. I have no idea what she's that Channing Tatum's wife? No. Yes. And I know who it is. She's so pretty. Look up. I'm scared to get she says the name. Way off. Yeah. She said, Maya.
Okay. Take a minute, write these down, and see how many of them you can do. And we'll come up and put them on the board one at a time.
That's Miley Cyrus. It's not Miley Cyrus. She's Canada from You guys would be like, oh my god. It's the first one.
If you can't see them, feel free to come up.
I have a broken nose. I can't smell anything, but I promise it. I promise it was the best. Honestly, not.
Karen, did you ever pass?
I'm just laughing.
The printer was broken.
Seriously.
Broken.
Okay.
And, yeah.
The mystery It's coming up. One, two.
This one.
Oh, you
Have you done all these?
Yeah, but like.
Yeah. Good. I want you to try them all, and then yes, we will put them up there one at a time.
Hold on. How much did you sad. I actually wish I did. Halle Berry. Yes, Halle Berry. No, that's not Halle Berry.
Katie,
Her hair's.
yeah, you guys, not important right now.
Jessica. Jessica. Yes.
Yes.
That's what she wants. I put the pieces together. You did. Which is so nice.
Okay, Ethan, did you have one you said you thought you could put up there?
She's a blonde.
You don't?
I do.
Okay, well, we can only do one at a time, or maybe two. Maybe we can do two at a time up here. So, which one are you doing, Olivia? Number one? Okay, Olivia's gonna do number one. Do I have somebody come up and do number two? or another number, whatever number you want that number to. Okay, now the rest of you should have number 1 and 2 at least tried. Okay, Olivia said that problem number 1 was a decay problem, and the initial value was 2.5. Now, Olivia, what was the percentage of decay? It is a decay problem. What is the percent of decay? 70% decay. Very, very good. So she has a 70% decay, and her initial value is 2.5. Does anybody have a question about that? Number 2, Kieran's doing that right here. He started out by saying A was 4. Was he right in that? Yes, he's exactly right. And then he said, okay, let's wait a second. I think I see here. You have y equals 4 due to the x. So then you said 4/9 equals 4 times b squared. Now, let's talk about this for a minute because he's made an arithmetic mistake, and I want to make sure nobody else does this. It's very easy to make this mistake because fractions are involved. We need to get this 4 moved over here, right? So we're going to divide by 4, but since it's a fraction, instead of dividing by 4, I will multiply by 1/4. Is that what you did?
Yeah, that's what I was doing.
So 1/9 equals b squared, because those 4's are going to cancel. So we're going to have 1/9 equals b squared, which means b will equal what? 1/3. Yep. So what is our answer then? If b equals 1/3, our answer will be y equals 4 times 1/3 to the x. What do I do with this guy? So it's going to be 1/16 to the 3/4. What does 16 to the 3/4 mean? Uh-oh. The 4th root of 16 cubed. What's the 4th root of 16? 2, and 2 cubed is 8. And this one right here, what do I do with this one? Flip it, so it will be 3/2 to the 2nd. And 3/2 to the 2nd is 1/4. Write an exponential function representing an initial value of 42 and a 12% increase. That's easy. It's going to look just like this. Only what are the numbers going to be? Y equals 42, 1.12 to the x. Remember, your percent increase is how much more than 1 you are. So 1 plus 12%, 1.12. Okay, stop. This one we can do. Log base 10 of 10 squared is 2. Uh-oh, what about this one?
1/4.
This is the log base e of e to the 1/4, which is 1/4. Perfect. How about this one down here? Just learned it today. 10 to the negative 2nd. 1/100. This one, e to the 4th. Very, very good. Very good. Okay, you have an assignment tonight? How about you surprise me and do it? Here, get off your iPad. Okay, Maya, what day is this?
Why not?
12/3, that's next Wednesday maybe?
Julia, when do you get those papers?